Class, as you can tell from the last slide, the next concept in biomechanics we're going to go over is a lever. I'm going to try to break these levers down into 3 separate videos for you. We have first class levers, second class levers, third class levers. This is a seesaw. This is your typical first class lever. Typical first class lever, you're going to have a resistance force. Here's my resistance force. I'm going to call it a 40-pound dumbbell right now. Resistance force, it is pushing down on our seesaw, on our lever. Resistance force typically is a force generated by a source external to the body. Like I said, that's my 40-pound dumbbell. A lot of times this could be classified as gravity, could be inertia, could be friction. Basically, it's anything that's acting against our muscle. So, we have our resistance force right here. Then you have a fulcrum. You go back to the definition of lever, the fulcrum is the pivot point right there. Resistance force. Now we have our muscle force. Muscle force is on the opposite side, and in order for this to stay balanced, we're going to have 40 pounds muscle force pushing down. That's going to keep it balanced. Basically, our muscle force is a force generated by biochemical activity or the stretching of non-contractile tissue. This tends to draw the opposite ends of a muscle toward each other. This right here is your first class lever. Now, we also have moment arms. A moment arm acts perpendicular to the force and runs indefinitely. So, we technically have 2 moment arms here. We have a moment arm for our resistance force that is running perpendicular indefinitely. And we also have one for our muscle force. Once again, running indefinitely. This diagram right here, notice the fulcrum. It is located almost in the center, as close as I could get it to the center of our teeter-totter. That means there is no mechanical advantage either way. If I were to move that fulcrum, now I am creating a mechanical advantage. So, if I move this fulcrum this way, this creates a shorter moment arm, so shorter resistance moment arm. This moment arm would be longer. Therefore, I have a mechanical advantage over here. My muscle moment arm is longer, it has a mechanical advantage. Same thing, or actually, exact opposite if I move it over here. Muscle moment arm shorter, now our muscles are at a mechanical disadvantage. Why is this important? On the next slide, you're going to see a tricep extension. That's a first class lever. I'm going to give you an exact opposite action, the bicep curl, and give you an example. Let's pretend these markers right here are 100 pounds of lumber or firewood. If I'm carrying them in my palms right now, the mechanical advantage is going to go toward the resistance force. This is the moment arm for the resistance force. My moment arm is very, very short from where the muscle attaches, and so it's a very, very short moment arm. What happens if I move this 100 pounds and put it closer to my elbow? Now I'm creating a biomechanical advantage for the bicep, and it's a lot easier to carry. I can carry twice as much wood or carry the wood twice as long. This becomes important. That was an isometric type activity, and something with mechanical advantages. They may be easy to point out in isolation exercises, like I just said, a bicep curl, tricep extension. They also carry over into complex exercises like your squat. In a couple of weeks, I'm going to give you a demonstration of a squat, and we have a back squat and a front squat. Those will be the 2 that we look at the most. The back squat, the shoulders bars on our back, obviously. The shoulders tend to move forward and they're going to be in line with the knees in the bottom position. This creates a long, long moment arm for the glutes and hamstrings and a short moment arm for our quads. This makes it a hamstring and glute dominant exercise. Now our front squat, our shoulders stay directly above our hips. This shortens the moment arm for our glutes and hamstrings and lengthens it for our quads. This makes it a quad dominant exercise. So when we're talking about levers, you got to think about the muscles and how changes in exercise, like I just noticed a back squat to a front squat, an incline bench compared to a flat bench. Those are all going to affect the levers of our muscles and the moment arm of our muscles. So each exercise is going to be slightly different.